你们好。
好。
I'm sorry, but this is the only thing that I can do in Chinese. I would love to learn your language because I love it. But maybe someday. I'm glad to be here. Thanks for inviting me. And this is a huge audience. When I was preparing my presentation for today, I did not have the talks that I had last night with, when I had dinner with some Taiwanese people from a very good company here in Taiwan. And if I had had this talk before, the presentation might have been a little bit different. We had in our human history 12,000 years ago, the first big revolution of mankind. That was the agricultural revolution. It took 12,000 years, almost 12,000 years, till 250 years ago we had the second. That was the Industrial Revolution in the mid of the 18th century. What we experience today is the third one. Some people like to say this is the fourth industrial revolution. Maybe it's just another step in doing it better, making it more efficiently. I think what we experience now is a digital revolution. It comes in the look of the fourth industrial revolution, but it will be a change of the whole society. And the biggest change that we experience is, like Mark said before, we were talking about it in the morning, I guess the most important thing of this event, the most benefit that you can get from this forum of SAP is to be together, to be connecting yourself, to connect to other companies, to connect to people from other regions, from other industries, to learn from each other. That's what digitalization is bringing us. When I was in Qingdao 2 years ago, I was visiting Haier. Yesterday I learned there's a Taiwanese company, it's better than Haier now. In terms of smart factory, what I heard yesterday and what I saw, this Taiwanese company is better than any company that I know from Germany. Just to let you know that we all have to learn from each other. But that doesn't change the necessity to think about what's the next step, even for the company who's best in best production today. What's the next step? That was the discussion last night. It was very interesting. And Haier, one of the first screens that I saw 2 years ago was this screen that showed Haier is having a strategy mixed out of Industry 4.0 from Germany, Made in China 2025 from Beijing, and Industrial Internet from the United States. But they have their platform strategy for Haier. And I will come back to that in the last slide. Half a year later, I was having a discussion in Dongguan. It was the company called Wonderful World, Wonderful Group. One of the things that they are producing is ceramics. I wanted to see their processes because they wanted to show me how they are doing it, but then everything changed, like it's always doing here in China. It can happen, you plan something, but everything's coming different. So the difference was I was not going to the company, to the production line. They wanted me to talk to the people in the company, to a couple of hundred people, were talking to me there, and it was a live video conference to 500 more people in 2 other locations of the company. They wanted to talk with me about Industry 4.0 and how important that was for their company. By the way Asian people are talking to each other in the companies is much more open than I ever experienced in Germany. We are, if there is the CEO sitting in the first row, like in this discussion, you see him in the middle. He was sitting in the first row, but it didn't be a hindrance for any of the members of his employees to say what they wanted to say. And they were asking questions like, how can you say Industry 4.0 will be great? I found industry is boring and stinky and dirty. That was saying some people standing just 2 meters behind the CEO. But one of them said, Mr. Sendler, if Germany is so good in Industry 4.0, and we believe you are very good industry, then maybe you can tell me which company in Germany could we buy to make things like this. That was one of the products that they showed me in the museum of the company. And he said, which company could we buy from Germany, which makes it in Industry 4.0, so we can have this product done much more, much quicker and individualized, and so he was making fun. And his CEO afterwards said, you have to think about your place and your position in this company. And I was answering, well, I'm sorry, that's not our profession. It is not something that a German company will bring to you. Every country, every company, every region has to think about what is our next step in industrial revolution, what will be our products, what will be our services that you have to make a kind of machine that's able to digitalize the Chinese letters and to make a product like this happen, which is done manually today. Very fine handwork, manual work. It will be digitalized, I guess, within the next 10 years. So let me try to lead your attention to some points that maybe not be talked about every day when you talk about Industry 4.0. I'm not going to go deep into technological details of Industry 4.0. But one thing is the value chain of the industry as we know it for 250 years is changing fundamentally. That's the first thing. The second thing is that I want to talk about. Digitalization, we're talking about it for 5-6 years now. It's not new. It started in the middle of the past century. We did not talk about digitalization, but it was the beginning of the digitalization in the middle of the past century, and I want to draw your attention on a little look at the history of digitalization to better understand what we experience today. The third part is I try to give you some examples of German companies trying to find their way with Industry 4.0. And last but not least, I want to talk a little bit about artificial intelligence, machine learning, cloud technology, what it has to do with the next step of the digital revolution in the industry. So let's start with the value chain. You all know this. It's done by most of the companies. They have this picture somewhere in their presentations. They show the value chain as we all know it. Some guy has a good idea. He finds somebody who's designing it. It will be developed. it will be tested, it will be produced, sold, and then you're done. The company is done. That was the industry until now. And 99% are doing it this way today. You're selling some product to your consumer, and he's paying for it, and you're done. The value is created. The view is from the manufacturer to somebody who should buy this product to make it worthwhile to manufacture it. That's how industry is thinking today, because that was the thinking of the past 250 years. Google came up. Google is not producing very good things that you could use at home. They might start with it, but for now, for the past 20 years and more, they are producing services with a smartphone and thinking about making business with data. That's what we're talking today. And they have the most important principle for the Google internally for their employee is this: the user is in the first place and everything else follows spontaneously. The user, not the consumer. Because the consumer of Google is you. These are the companies paying for advertising in Google. That are the consumers of Google. The users are we all, the private persons, using Google as a search engine. And if Google is able to make us content with the use of the search engine, then they can do their new business with the companies who are buying advertising with Google. This is very important to understand, because this will happen to all of us, to all the industries, because all industries will in the future think about using their products with the service integrated, connected to the internet. And when you saw the last picture, operation and service was in gray. It was not important, because maybe that's doing another company, not the manufacturer himself. But now, it may be the most important part of the value chain, because after the product is sold and connected to the internet and starts being operated by a private consumer or by a company using a machine, then life starts. And then if the company was able to find some business being done with the data produced by the machine in operation, it could start the new value chain that's being created while the product is in use. So the most important part of the value chain is what was not important until now. It's after the product being sold. And I come to that with an example a bit later. But to do that, it's necessary to think about that the view of the whole participants of this process is different. It's not anymore the manufacturer looking to the world who could buy my product. It's the manufacturer wanting to know, what Mark said, wanting to know what is the user, the potential user of my service based on my product, wanting. So I have to think about the thoughts of the user, who might not be the consumer, because he might not be buying the product. He might only use it by leasing, by sharing it, like sharing cars. Mark was talking about it. Therefore, this is the reason why data are becoming the most important resource for every industry in the world, because only if you're able to have a data chain that's going from engineering, from the first idea, over engineering, testing, producing, selling, marketing, maintenance, to the use of the product at the customer side. Only if you're able to have these data available, then you can have this data chain that's going back and forth, and you can ask, how is the product used at the customer side? How is it operating? You can compare the data that are delivered by the product with the data that you generated in the engineering. The designer, what were they thinking the product should do in operation? And they can compare it with what they experience from the customer, or the user, better to say. And they can think about, how can I improve what I'm doing in engineering? And they will be producing and selling and offering a better product, because they know better how it's being used in the reality. SAP gave me a picture like this, which I find very good, because it's showing this data chain that I was talking about, going back and forth. That's what many people nowadays name a digital twin, or digital twins, because it's not only one. It's one from engineering, as designed. It's one from production, as built. But that's not all. As maintained. What do we need to know to maintain a product right? What do we have to know about the suppliers for the spare parts? As operated. That may be the most important digital twin in the future, as I told you before. And the most important thing, that's what I added to this picture, it has to go back and forth. All those digital twins have to be consistent. They have to talk to each other. They have to be connected, so that the operator knows what the engineer was thinking, and the engineer understands how the operator has problems. So the next thing, I think it's always important to realize we are not coming, digitalization is not like a miracle coming from artificial intelligence. It was not artificial intelligence inventing the smartphone. It was a human being. So everything we experience today is done by humans. And so it's necessary to realize, where are we today, where are we coming from? The first part of the Industrial Revolution was the second half of the 18th century, the steaming engine, invented in France, but best produced in Great Britain, Watts. And it was goods that were produced that everybody could buy. That was new. Before, you had to go to somebody to make something for you, for yourself, individualized, like we are going today, again, on a different level. But now it was possible to produce goods for everybody, to sell them. And only 120, 130 years later, beginning of the 19th century, we had the second Industrial Revolution. Ford said, if every employee of Ford is able to buy my car, my company will be leading. And it was true, because he was able to produce goods that his workers could buy. That was the beginning of mass production, mass-produced goods 1910, 1913, I think it was the assembly line from Ford. And until this happened, 1970 about, everything went in the same direction. The Industrial Revolution was something that was coming from France, Great Britain, and the United States, going all over the world. Every country was starting to build their industrial production. They looked for what was coming from these three countries. And the computer changed everything, not in the way we are experiencing a change today, but it changed all the way industry was working. And it first changed the way that it made a difference between Europe or Germany or the German-speaking parts of Central Europe and Japan, I have to add, on the one hand, and on the other hand, the United States. And it looked like this. We had something that we today call the Third Industrial Revolution. When it happened in the 70s, so when Germany was becoming the leader in programmable logical controllers, and when the microchip was used for automation and for integration into mechatronic products, that was starting in the 70s. Nobody was talking about a third industrial revolution. Everybody was thinking, well, this is automation. This is next step of efficient production. But that was what Germany was focusing on, mechatronics, products being produced with the support of digitalization in terms of using the computer software like SAP, like Dassault System, like IBM, like all the others, standard software to support how products can be developed and produced. And by the way, for a couple of years, we were now world market leaders in doing this hardware. On the other hand, we had a complete different development. The United States stopped to produce. They stopped to focus on their industry. They only focused on IT and had an IT revolution. They didn't have a third industrial revolution. And it's funny enough, if I was talking about these things in the past years, I was realizing the United States people are now talking about the third industrial revolution because they missed the third one that we had in Europe. The industry is going down, was going down for 20, 30 years in the United States, and it is still down. It's very down. The result is Mr. Trump, because he was elected by the people who are not having work today, and that makes you think about it's very important if the industry does a good development in the next step. For now, it's the digitalization, it's the fourth industrial revolution. By the way, the United States also, now they are talking about the about the fourth industrial revolution too, because they saw what we were doing was not too bad. It was Industry 4.0 in 2011. Who knows what else was important in the year 2011? Has someone an idea what I could mean? Nobody. Who knows what is IPv6? Not too many. IPv6 is the Internet Protocol version 6. It's a standard from 1998, but in the year 2011, it was the first time that the world groups were deciding this has to be the standard in the future because the former IT protocol v4 was done. It only had 4.3 billion internet addresses. So your IP that you were registering in the internet when you start your computer and go to the internet, 4.3 billion were done. They were forgiven. So it had to be IPv6. And a German magazine said, this IPv6 is like you have enough internet addresses to give quadrillions of internet addresses for every millimeter of the earth, including the water. So nobody is doing that. But that was the point where we could think about having every product, every machine, every part having its own internet address, and that is the precondition to be able to collect data, to analyze data with sensors who have their own internet address, with QR codes on everything with their own internet address, to be able to analyze everything on Earth via digital products. That was 2011. And Industry 4.0 was founded in the same year. That's the reason why Germany is a little bit far ahead from the other industries. The only difference, because at that point, the research in Germany and the government was deciding we have this initiative, Industry 4.0, for the next step of the Industrial Revolution. It's almost the same what is meant by industrial internet in the United States. Therefore, it's a good thing that Hayo was saying Industry 4.0, Industrial Internet Consortium, and Made in China 2025 are the three pillars. Industrial Internet and Industry 4.0 are focusing on product-based services. There's a German researcher who said a cyber-physical system is a system which is connected to the internet and is having integrated services via internet based on this product. That's a cyber-physical system. But that was the start, 2011, IPv6, being able to make every product being connected into the internet. Internet of Things and Services, IoT. That's the connection between the both sides. So maybe they are coming together again, which will be different. It will not go the way like Trump is trying to do it, with some regulations for the economy, which will not be very successful. They will not bring the work back that was reduced in the United States. But there must be some combination between hardware and software. It's not possible anymore. In the past 30, 40 years, it was possible to say, well, this country is concentrating on the hardware. This country, Taiwan, is concentrating on electronics. China is concentrating on textile and mass goods, cheap production. United States is concentrating on Google, Facebook, Amazon, and so all those internet giants. This is not possible anymore. Because if you want to have internet-based services integrated in your products, you need all. You need the software, you need the service, you need the artificial intelligence, you need the hardware engineers, You need all. So there will be a combination. And it's not only that the former rankings of the industry countries are not fitting anymore to today. It's also Greater China coming up behind the scene as a region where everything can happen. Like I was telling you in the beginning, like I was realizing last night at dinner, it could be possible that somebody who is just now focusing on producing more efficiently than any other company the products he was producing different in the past 10 years, that he's thinking about what could be his products and services and business models in the next 10 years. It's not useful to think about the next 20 years because it's going too fast, what's happening at the moment. But this is very important to see. Greater China, the Asian region, will play a big role. It's not only the real good strategic decision of Made in China 2025 in Beijing, which was 2015, with 3 10-year plans with which China will want to be one of the leading high-tech industry companies and countries in the world. I think if you look at the history of Asia, you will find when we in Europe started to think about philosophy, about science 2,000 years ago in Greece and Rome and other parts, we were finding the best thing is analytics. We're going deep into the atom, into everything. We wanted to know what are the deepest parts of every little thing. That was making it possible to be leaders in the Industrial Revolution 250 years ago, which was not happening in Asia but in Europe. And in the European people moving to the United States. But in Asia, you had philosophers that were thinking about relationalism, thinking about more, it's important how one thing connects to another, what one thing is doing when others are doing different. You were thinking about countries doing something, regions of China doing something different than other regions of the same country, how China was reacting to something in the world. This thinking in relations between things and people and organizations is the same that we have today with digitalization. We are going to a industry development that produces systems of systems. A car in Germany is connected not only to the driver and to the manufacturer, it's connected to the traffic system, to the government, it's connected to the weather report, it's connected to the maps provider, it's connected to everything. So it's a system of many, many, many computers within the car, and this complex system is connected to other systems who are as well complex. And this thinking of systems is something that is in the blood of Asian people, I believe, because it's 2,000 years old. And that could be something that makes the fact that China, Greater China, is coming up behind this whole scene makes it very interesting in the coming years how this will change the way industry is developing further. So let me come to some examples of how we in Germany realize the potential of Industry 4.0 and the new thinking I was trying to explain to you in some words. What does it mean? If you look at Bosch, you're maybe thinking of household appliances, you may be thinking of the supplier of the automotive industry, of software for cars, or the traffic, or smart cities. Bosch was showing this 2 years ago. It's a Bosch IoT gateway. It can be used for everything. It can be used to put everything into connection with the internet and do something with it. For example, used to connect this latte that was used 1887 by the founder of the Bosch company. You have to do it with your feet. It's driven by a pedal. And with this little device, you see it standing up there, with this little Bosch IoT gateway, it's possible to connect it to the internet and to have the data of this 150 years old machine on the screen via internet. You can see how it works, if you are doing right, if you're driving it fast enough, if you have to be careful because you need some spare part. You can use it as if it would be a machine that was made for Industry 4.0, which means you're able to use Industry 4.0 even if the company is doing its work with very old machines. It's very easy to connect them. You have to know how. Simple example that is more or less the same, like what Bosch was doing, is showing that everybody can do something like that. Harting was a company that was known for electrical connectors until 2016, when they were winners of an award of the Hanover Fair, the Hermes Award, with this little machine that you see there on the left, a Mica computer. That's the same like the Bosch IoT gateway, but you can use it for every machine, not only for Bosch, for everything. You can use it with every software. You can connect any machine, any device with this little computer to the internet and collect data, analyze data that is coming from this machine. But this is something a company can't do on its own. So that's the second part of why is connecting, collaboration, team working the most important part of the new digitalization that we are experiencing today. Harting was founding a network in 2016 already, and in 2017 they were on the next Hanover Fair. They already had a booth for the Mica network. There were 60 companies that were partnering with Harting, and it was software developers, app developers, software integrators, system integrators, people who were bringing artificial intelligence, algorithms for machine analytics. So this network is the next step for Harting, from a producer of electrical connectors to a provider of an industry platform for everything in the industry. Other example, land machinery. Company, about 8,000 to 10,000 employees in Germany, in the north part of North Rhine-Westphalia. They are producing land farm machinery for many, many years. And it starts at 1913, maybe that was the beginning of this company. So for 100 years, they were producing mechanical products to make land work easier. Then there were mechatronic products with the third industrial revolution. And now they are producing intelligent systems. What does it mean? They gave me this picture. Every machine from class that's on the field, and you will not see any people there. It might be not necessary to have any man sitting in one of these machines. But they are connected, they are driven automatically, they are working on the field better than any machine was doing before. This is connected agriculture. Let me give you my personal, very personal vision. In 100 years from now, it would be possible. Today we have in Germany, in agriculture, about 1% of the people who are working in agriculture. I guess, and only half of them are working for money. The others are owning the land and doing that. 1%. I guess 100 years from now, maybe it's 1 or 5% of the people working in the industry. Maybe. But we have to find the way to that situation. We have to find our way. Connected agriculture. This company was building a greenhouse, which is a training. I saw this picture. Thank you. This greenhouse was built at class as a training facility to learn how digital value creation will be done in the future. That's not making money. But it's another idea. How can we use the competence that we have in our industry for something new? And this is one more example. I have to show this. Wastewater treatment in Cochem. Kaeser is a German customer of SAP using SAP software for driving the machines that are used for compressed air. For example, in a wastewater treatment, but also in every company. Every industry company will use some machine for compressed air, some compressor. They decided to go from compressors to selling compressed air. How do they do it? They found a nice way. They are selling their machines to a leasing company, and they are leasing their own machines back and put them to the company, like a wastewater treatment company, and let them work there. And they are selling the service of compressed air with a guarantee of having it running, availability of the compressed air, 95% a year. Completely new business model. It's working. SAP is showing with Leonardo platform and the HANA platform, the cloud platform that they are delivering today, they are able to deliver software that integrates the software and data that is coming from all the standard software products of the past. All the software that you are using today, that's traditional products of the past 30 years. That has to be integrated. How? From the left side, it's coming from products, from devices, from edge computing, from sensors, from mini cameras, from digital devices of any kind, because they are in the internet, so you can collect the data. Combine it with the software data coming from engineering, from design, from other departments. And what can you do with it? That's above. There are the services that you can think of. And maybe this forum will be a good chance to talk to other people and to have ideas how these business models could look like. AI, machine learning, cloud platforms, you might be surprised, but the first ideas of artificial neuronal networks was in the 40s of the past century. So it's more than 70 years old. But it took artificial intelligence until 2013, 14, until the cloud technology was ripe enough, until the computer were powerful enough to make it happen that we can use artificial intelligence now in every product. And what I found 2 weeks ago, the IoT vendors like IBM Watson, like Microsoft Azure, like Amazon Web Services, I guess all of them are here in the forum, or part of them. They are focusing on business IoT because they see that the most important thing for the next 5, 10 years will be the industry, not consumer goods, not smartphone, not tablet PCs. It will be what the industry is doing with digitalization. And not only this, what I saw from a picture from SAP, using it to see the consumption data of windmills all over the world in every region and to be able to analyze it and to see when you have to bring some spare parts. It also brings together every company to another who was a competitor before. Mark was showing something where Microsoft was on the sponsors of this event are competitors to SAP in some parts of the economy. In others, they are now working together. They are partners. This, what I show here, is MindSphere is an industry platform of Siemens. And you see the partners in there. SAP, of course, is one of them. Intel is one of them. Amazon Web Services. You can see them all. This is how digitalization works. MindSphere World is a platform that Siemens built with 18 other industry companies, machine builders, so they are able to offer industry apps, services for other industries over this Siemens platform. So my belief is in the future, we will not have this kind of economy that we have today, where you go to the market or to Amazon and buy some products. We will have a platform economy in the middle of it all, and it's important what kind of services can you get there. Another example, Atomos, that's an also in the industrial Internet of Things platform from competitors of Siemens. They teamed together, connected themselves as small and medium companies to be able to do the same like Siemens does, with an industry platform called Atomos. And this is showing that digitalization is not only replacing work of human beings, it can be very, very useful. This company is an SAP customer, Hakusan, in Japan, and he invented an app that enables you to have your mobile phone as an indicator for earthquakes. Your mobile phone registers when it will be coming. It doesn't matter where it lies, on the table, if you have it in your pocket, this mobile phone realizes an earthquake is coming. And it's many, many people who will be helped by systems like this. And back with my last picture to where I was beginning, Cosmoplat is the platform of hire. They are going there for more than 10 years now in the direction of platform providing, and they have now more than 320 service users over their platform, more than 41 million people who are using it to customize their orders from hire, and more than 21 million networked devices that hire produced or partners of hire produced. That was on Hanover Fair 2 weeks ago or 3 weeks ago. Yes, so I guess connecting the world with digitalization will bring us to the next level of human society, human economy. Thank you very much for your attention.